Good morning and welcome to today's webinar on the innovative additives for anti-corrosion or high temperature coatings, brought to you by ICL Innovation and NineSigma. My name is Jonathan Yakasha. I'll be your host and moderator for today's webinar. Before I share the plan for today's webinar, we'd like to learn a little bit more about today's attendees, so we have a quick question for our listeners. In just a moment, I'll be putting a question up on the screen that I hope you'll have the opportunity to answer. Give me just one moment here. On your screen, you should be seeing a question saying, what is your area of expertise? 1, I develop anti-corrosion additives. I study corrosion. I develop anti-corrosion coatings, or others. Please take a moment to respond to this question. We've already got a number of answers coming in. Thank you very much for all of you who have already responded. I'll keep it up for just another moment or two. Okay, while the last few attendees respond to this question, I'm going to go ahead and begin talking about today's agenda. I'll begin by introducing our speakers, who will then share the details of this project. After that, we'll go through a live question and answer session with questions submitted by you, our attendees. At any point during today's webinar, please feel free to submit your questions via the Q&A chat box. We'll keep track of the questions that you submit, and once we get to the Q&A portion of today's webinar, we'll begin going through those questions. At this time, I'm pleased to welcome the following speakers to our webinar today. Representing ICL, we have Tony Gashui, PhD. He's the Global R&D Leader. We have Sandeep Goyal, Business Director. And we have Ziv Koav, Business Development Manager. And from NineSigma, we have Kevin Andrews, Senior Program Manager. Kevin, as you're the gallery moderator, could you please introduce us to the ICL Innovation Gallery?
Sure, thanks, Jonathan. NineSigma publishes galleries for a variety of clients. The ICL Innovation Gallery is just depicted here on the slide. It's available at ninesites.ninesigma.com/web/ICL Innovation Gallery. That link will be provided to you later in the presentation. This gallery contains a variety of needs and include the categories for featured needs, plant nutrition, engineered materials, flame retardants, microbial solutions, and paint and coatings.
Great, thank you very much, Kevin. Now, Ziv, Sandeep, would you please tell us more about ICL Innovation and your approach to open innovation? Ziv? Excuse me, just one moment. Go ahead, Ziv.
Hi, okay. Can you hear me?
Yes, Ziv.
Okay. So, ICL Innovation, just to give you a background on this, is the open innovation arm of the ICL group. We started our work about 3.5 years ago, and we serve the entire group's open innovation needs. The way we do it is that we go to the business units, we basically ask them what are their technological unmet needs, what are those technologies that could bring them to the next product, the next service that they can offer. We then go and publish those needs, and we do this through open innovation portals, and the main one is the one that you see here with NineSigma on 9 sites. So that's why when you go to the site, and there's going to be a link at the end, you're going to see much more than just this specific need that we're going to speak about today and that you're going to ask questions about. And these needs might be of interest to you because, as an example, we have a need for a heat transfer fluid that can withstand elevated temperatures, which possibly, if you're responding to the need right now, you would have an interest in this additional need as well. So I really recommend that you go and browse through the needs. They're in the areas of agro, in the areas of food additives, engineered materials, and others. So going to this need, so we seek to reach a global audience of engineering technology experts to develop collaboration through open innovation. You're probably familiar with open innovation, and I think that we offer a very nice and flexible model, and I think that researchers and entrepreneurs have no real difficulties in working with us. All the IP issues, confidentiality, and so on are things that we deal with on a daily basis, and so these are pretty much sorted out. With NineSigma, as you can see here on the next bullet, NineSigma has a proven method for publicizing the needs, reaching out to communities of interest, and this is a public that we really, an audience that we really want to reach and hear them. And we actually have projects that came out of this engagement with NineSigma from a few places in the world. So this is not something that we just started. We don't know, how to work with this. We actually have running a project in this. The third point, ICL Innovation seeks this fund development program. So we're here not only to hear those ideas, but we actually give money to support the continuation of the research towards application. What is important for us is to reach in the end some sort of a technology that would be the basis for future products in ICL. Jonathan, can I ask you to move to the next slide? Right. Okay. So in this webinar, we focus on advanced additives, the business unit in ICL. Sandeep is going to present this and the background on ICL, on the entire group, in just one slide. I think at this point, I'm going to hand over it to Sandeep. Thank you.
All right. Thank you, Zev. So a quick introduction on ICL. ICL is a vertically integrated company back to the mining of rock. So we mine things like bromine, magnesium, phosphates, etc. We then, through a series of blends and reactions, we create downstream solutions for our customers. So internally within ICL, from a P&L standpoint, we have three segments. We have the fertilizer segment, performance products, and industrial products. Externally, our face to our customers is in the form of agriculture, engineered materials, and processed food, and that's the last column on the right. Tony and I are part of the engineered materials group, and within the engineered materials group, we have what are called growth platforms. One of those growth platforms is surface coatings. So next slide, please. So in the space of surface coatings, we went through a very detailed process to understand unmet needs. We started by assessing the market, and that really entailed a lot of secondary market research. We then identified a number of substrates to focus on. Metal was one of those substrates. Then for each of the substrates, we segmented by application. So in the area of metal, as an example, we looked at all the different metal applications onto which coatings are applied, and we prioritized those segments based on some very specific criteria. For each of the segments that were prioritized, we then identified key customers with whom we wanted to conduct voice of customer interviews with. These were very structured, qualitative and quantitative discussions. Based on the information gathered and the analytics completed, we identified literally hundreds of unmet needs. We were then able to categorize those unmet needs into 2 or 3 broad areas. And then under each of those broad areas, we went through an internal innovation process to identify projects. One of those projects was anti-corrosion for high-temperature coatings. And that's what Tony and I are here to talk to you about today. So at this point, I'll hand it off to my colleague, Tony, and you can take it from here.
Okay, so thank you very much. And What I would like to do is spend the next few slides to discuss the technical aspects of this unmet need, because I realize most of the audience participating in this session are going to be technical. And so I wanted to start with the next slide, which is a high-level definition of what we mean by high-temperature coatings. So there are different types of high-temperature coatings out there today, and not all of them are similar. What we're looking for specifically are coatings that are applied to steel. Most of the times this could be regular cold rolled steel, could be cast iron, or it could be any type of metal that will withstand high temperatures. So we're not specifically talking about coatings applied, say, to aluminum. We're really focused on steel. And so the type of temperatures we're talking about here can range anywhere from, say, 150 degrees C on the low end up to 650 degrees C. And for those in the audience who are thinking in terms of Fahrenheit, so we're talking about, 302 degrees Fahrenheit to about 1,200 degrees Fahrenheit on the upper limit. So these coatings do not see those temperatures throughout, but they do see that temperature in terms of cycles. So what we want is this coating to be able to resist these temperature fluctuations during service life or during the application of that coating. So the coatings can also obviously be subjected to low temperatures, and so we want the coatings to remain intact, but for the most part what we're mostly interested in is that the coating still provides corrosion resistance at the high temperature end. So if we move on to the next slide, this is a nice representation of what we mean by a coating for high temp coatings. This is a cartoon that depicts typically how these coatings are applied. So there could be a 3-layer system or a 2-layer system. Here what we're looking at is a 3-layer system. We're not as much concerned with the outer 2 layers, layer number 2 and layer number 3. We're more concerned with the layer number 1. And in this layer, the corrosion inhibitor or additive that we're looking at must be able to perform its properties of improving the corrosion resistance of that coating. And so that layer will be tested in isolation of the subsequent 2 layers. So to keep this in sort of focus, anything we look at develop, we're primarily going to be looking at how does it perform in a single one-coat system. Okay? So that's something I think the audience ought to pay attention to. So if we move on to the next slide, these are some examples of what's out there in the industry today. And so, again, the first photograph, the picture on the top, really depicts the substrate. In this case, you have a resin, which is a high-temperature resin. So typical high-temperature resins could be silicon epoxy, or polyamides. And oftentimes you see combinations of different resins, depending on what the desired end result of that part is. So we're not limiting ourselves to just silicon chemistry, but you could have a epoxy-modified silicon resin, for instance. And as far as the pigmentation goes in these coatings, there are some examples listed here. Typically, these coatings can have as much as 20 to 30% of the pigment. And the corrosion inhibitor is really where our focus is. That material needs to provide good corrosion resistance under high temperature. And as I will talk later and give some specific examples of how we measure the corrosion resistance. And then the last 2 additives that you see on the table below are the solvents. And sometimes in this coating you'll have additives, things like defoamers, etc. So with that said, I think the focus for the audience should be on, we're really looking to improve the corrosion inhibiting package here for a coating that's going to be applied on steel. So let's move on to the next example. So this is an example I think a lot of us who are good at either barbecuing or grilling are very familiar with. I thought this was a good visual close. What are the types of coatings that are being used. This happens to be a grill that has had obviously some service to it, and as you can see here, the casters that are below the grate are all corroded. And this happens obviously over 1 to 2 years, depending on how this grill is stored, if it's stored outside, or if the customers are not taking good care of it in terms of cleaning it afterwards. So typically when you go out and you buy a grill, the grill will come with all parts coated, and you'll see a lot of these will either have shiny, black coatings on them. But over time, this is the kind of problems that we're talking about. So again, you can imagine that this grill sees extremely high temperatures. If you're grilling, you're going to exceed 500 degrees F, sometimes higher. But this is just an example that I think most people can relate to in terms of what we mean by better corrosion resistance. So what most people do today is once the grill gets to a point that looks like this, they just discard these casters and buy new ones. So what we would like to do is obviously help our customers develop coatings that are more resistant to corrosion. All right, moving on to the next slide, I wanted to again expose you to some other examples of where high temperature coatings are used. So beginning from the top left, these are the grates, again in a typical barbecue grill that you find in many homes. Most oftentimes these coatings have to withstand abrasion because, as most of you know, when you grill you'll end up with food residues that then you take a wire brush and you brush that off before you cook your next steak or poultry. So what we would like to do obviously is to be able to provide an additive that is going to have no impact on food in terms of food contact. So it needs to be environmentally friendly, but it also needs to be something that will not contaminate food. And I'll discuss later some of the elements that we're not looking to really focus on. The next slide over shows a pipeline system where you're conducting or ferrying hot liquids. This is a good example of a coating that again sees temperatures that range, again from 150 degrees C, depending on what the fluid is that is being conducted through that. The motorcycle, I think, is a good example that many people can relate to. The mufflers in this type of motorcycle see very high temperatures during the operation of this particular motorbike. So the bottom three examples are very similar, but again, to explain to the audience that high temperature coatings can take on different forms. Okay, so we're looking for an additive that can be incorporated into a coating. Typically, these coatings are going to be applied anywhere from 15 to 25 microns in terms of film thickness. Desirably, we would like to have coatings or additives which do not exceed a top end of about 15 microns. And the reason specifically for this is most of our customers who are going to be utilizing this sort of additives only use high-speed mixing. So they do not have the ability to mill or jet mill their coatings or dry mill their powders before incorporating this into paint. So we want to make this as seamless as possible to customers who will take an anti-corrosion additive and simply incorporate it into their coating system. So that's a key criteria, that the particle size needs to be relatively small. We move on to the next slide. These are some possible approaches that we felt may be of interest to some of those who would like to submit their ideas. We're obviously not limiting ourselves to phosphates or polyphosphates, but that being core to ICL's business, phosphates and polyphosphates would obviously get much higher receptivity than would, say, other types of chemistries that one may be envisioning. Combinations of different products may be one approach to achieve this, and we obviously are not limiting ourselves also to technologies in case somebody's thinking nanotechnology or some type of ceramic type additives, that will all be entertained. In terms of the next slide, please, these are some of the materials that we obviously have some grave concerns over. So we would like to avoid heavy metals, and a lot of these heavy metals are under severe restrictions in different parts of the world. But any materials that contain chrome, whether it's chrome 3 or chrome 6, we would like to stay away from. Lead, cadmium, mercury, arsenic, antimony, and zinc are metals that we would try to avoid as much as we can because of the strict classification and labeling criteria that these have. And if some of you are thinking organic compounds, I think the organic compounds would be fine as long as they do not volatilize during the operating temperatures of the coating. And this obviously limits how many of the chemistries that might be available to us. But typically with coatings like this, we would like to mitigate how much volatile organic compounds that we're introducing into the films. So I think with that, I've come to the end of the technical aspect of the unmet need. And at this point, we can move on to our next slide.
Great. Thank you very much, gentlemen. To our attendees, I would once again like to apologize for the audio difficulties that we encountered earlier in the webinar. We appear to have gotten those resolved at this time. Would also again like to reiterate to our attendees that if you have any questions, please utilize this opportunity to submit your questions to us via the Q&A chat box. We're taking the questions as they come in, and in just a few moments, we'll begin going through those questions. So if you have a question that you would like to pose to ICL or to NineSigma, please avail yourself of this opportunity at this time. Next, could you possibly tell us why our solution providers should be interested in engaging with ICL Innovation? Ziv?
Yeah, sorry, unmuted myself. Yeah, okay, so I think that the model is such that it's quite attractive to any proposer. The way we go about the proposal is that first it goes through an evaluation, right? And so what we want to see in the beginning is just a non-confidential concept in a way. Now this could be before the proof of concept or after the proof of concept. If it's before and we sort of evaluate it internally and decide that this is worthwhile checking, then we would go for a proof of concept stage, where we would actually fund this after reaching the appropriate agreement with the researcher, the entrepreneur. If it's a researcher, usually it's through the TTO, the Technology Transfer Office. And then we go into this stage of the proof of concept. When it reaches the stage that the proof of concept proves successful, then we would hand it over to the business unit for commercialization. So it goes through a number of gates on the way. It starts with this internal evaluation. We have an advisory committee. It's approved. Then it goes to the actual project stage, and later it moves on to the business unit for commercialization. The owner of the idea would actually benefit or be remunerated twice. Once, the first thing is that he gets funding for this proof of concept project or whatever continued research is needed to bring it to the point that we can give it to the business unit. And the second thing is, if it does develop into a product in ICL, then and commercialized, then possibly he would get royalties, depending on the agreement, depending on who owns the IP, if it's protected, etc., other commercial considerations. This whole process is pretty transparent. I would say that it's efficient. It doesn't take days, but it's pretty efficient. That's what we see so far, and we don't take advantage of someone as it comes to us. We're a big organization, and we try to remain fair in the contracts, and so the researcher or the proposer should be satisfied with the deal that is reached and the commercial terms that are reached. I mentioned in the beginning that we're kind of doing it on a daily basis, and so IP issues, if there are any issues about publication, if it's again a researcher in a university, these are all things that we can work out in the contract. They shouldn't be too problematic to resolve. And as well, on the confidentiality side, we start from a non-confidential brief, but then later, when we want to see the results of whatever was done so far, or if there's maybe a patent that was just submitted that is pending, and we want to see its content, then if we like the idea, then we would sign an NDA or a CDA and get access to this. So both sides are pretty much covered, and they can feel safe moving onwards and know that their interests are not in danger. Yeah, so that's basically it. That's the way that we work. One thing to note is that we are not a VC, right? We're not venture capital. So we usually do not invest in companies, in startup companies. Usually the way that it works is that we form a project within ICL Innovation and agree upon the terms in a contract. So that's just something to bear in mind, that we don't invest in a startup and then do an exit later. This is not the way that we will work. We can work with startup companies, but usually it's not in the way of investment. Yeah, so I think that's and just to mention again one thing that I said in the beginning. This is already running for 3.5 years, so we have already results of this, and we have already commercialized products from this. Yeah, that's it from my side.
Very good, Ziv. Thank you very much. We have now reached the portion of today's webinar where you, our attendees, are submitting questions to our panelists, be they from ICL Innovation or NineSigma, and we'll take the rest of our time today to go through your questions and provide you the answers during today's webinar. Once again, if you have any questions, please avail yourself of the Q&A chat box. You can submit your questions to us, whether they are process-related questions, how do you submit a proposal to ICL Innovation, or if they are technical questions about approaches that may be of interest or may not be of interest. As I said earlier in today's webinar, this is a wonderful opportunity for you to ask your questions and promptly get answers to those questions during today's webinar. Proceeding to the questions, we have this first question that I will hand off to ICL. In the example shared, a composite was not evident. Would the corrosion-resistant coating need to have abrasion resistance as well? Also, what are the film thickness constraints? Perhaps Tony or Sandeep would be able to handle this one.
Okay, so this is Tony Gashui. Let me take that one. Yes, composites were not shown in any of the examples, not for lack of applicability, but we really didn't think about composites, although they may provide a solution. We were mostly focused on coatings that are typically applied through baked systems. And these are the ones I showed in the example, the silicon-type resins or the modified silicones. The film thickness is something that we're concerned about because most of our customers have told us that the range of film thickness needs to be in the 15 to 25 micron dry film thickness. So this is a criteria that we really need to hit. And so technologies that we're looking to entertain need fit into this film thickness criteria. So we're not going to look at, say, materials that have a particle size that exceeds what our desired film thickness is.
Okay, very good. Moving on to our next question, and we'll stay with ICL for this one as well. Are there specific silicone vehicle formulations that ICL can recommend that might be preferred for potential particulate additives?
Yes, this is Tony again. Let me take that. Yes, there's formulations that we might recommend for anybody interested in submitting one of their ideas. This is something we can share with them directly. So that is something I think offline we can discuss which formulations we would use as benchmark formulations for the sort of evaluations we're talking about.
Okay, very good. Thank you, Tony. Our next question, I think we'll stay with you. Why not use porcelain coatings or enamels, which are pure inorganic with excellent thermal and chemical resistance?
That's a question that we also asked of many of the customers we dealt with. I think it goes back to cost. The way the porcelain coatings or enamels are applied today is slightly more expensive than traditional high temperature or bake coating systems. I have to admit that I've yet to find a grill being sold in the U.S. that is coated with a porcelain coating, despite all the benefits and advantages we know of, ceramic coatings. So this is not something I think the industry is ready to move on to, and a lot of that may be due to the fact that these coatings do not have the elasticity or the ability to be molded around parts like grates, etc.
Okay, very good, Tony. Thank you. This next question, I believe, would be answered by Kevin Andrews from NineSigma. I believe the questioner is asking about how to go about submitting a proposal in response to this problem. For the individual who submitted this question, if we're not getting the gist of what it is that you're asking, please go ahead and resubmit your question, and hopefully we'll be able to get to that. Kevin, if somebody is interested in submitting a proposal, how would they go about doing that?
Sure. So what you need to do is navigate to the NineSites gallery. We'll give you the link at the end of the discussion this morning. Find the topic title and click on that, and that opens up the need. And at that point on the page, there is a respond button. You would click that respond button and then receive an interface with some questions to answer, things like your proposed approach. You have an opportunity to upload documents. The key to all of this is that your submission be of a non-confidential nature. Do not disclose confidential or enabling information. Focus on the potential performance of your approach without disclosing confidential information. That proposal would then go through our system and eventually be delivered to the ICL folks for their review, and if they find it interesting, they'll contact you directly for next steps.
Very good, Kevin. Thank you. Turning back to Tony and Sandeep from ICL, what are the budget restrictions for a proof of concept?
Maybe I should answer this. This is Eve.
You have information to share with you? Absolutely.
Yeah. So we don't have an exact figure there. If it's a proof of concept project, so again, I'm thinking about academia. So in academia, you got the proof of concept, and so you say, I'm going to put one PhD on this. So this kind of has a price that is pretty much known. It has some range, here and there, but we wouldn't expect $200,000 for 1 year for just proof of concept. So I think that somewhere between, let's say, 50K to 100K is reasonable, depending on the number of PhDs or postdocs that they're going to put on it. If it's something that involves a private entrepreneur, so it just depends on what's there. But what we try to do is we try to stay in this proof of concept idea, and this pretty much limits the cost on its own. Because we're not looking to invest in companies, then it will not get to the millions right from the start. And even if we do want to invest later, then we would still go through those stages. We try to do it also in a way of milestones. So even if the total budget is going to be more than this, then we will try to divide it to milestones, or request the proposer to divide it to milestones. And then we have the ability to exit at those points where we realize that maybe this is not what we thought it's gonna be. So try not to give us something that has very long-term commitments, 3 years, 4 years. This is not what we're looking for a start. Later maybe, but not for the start. So I hope this answers.
Ziv, this is Sandeep. If I could just add a couple of comments to that as well. From a commercial business standpoint, just like any other project, we do an economic analysis on the degree of investment required, probability of success, and over how many years we plan to see returns. So at this stage, it's very difficult to say what that analysis looks like until we have a better idea of how well the solution actually works, and what kind of success we plan to see in the market accordingly. So that analysis will be done, and within the guidelines of what Ziv just highlighted, as long as we're within those guidelines and we have an acceptable rate of return, which we fully anticipate we would, based on customer interest, we would proceed accordingly.
Great. Thank you, Sandeep and Ziv, for those answers. Our next question, I think, would probably be best addressed by Kevin. The submitter says that they have recently developed a nano-based additive for corrosion for high temperature. If this individual would like to have their additive reviewed by ICL, Kevin, would they just need to submit a proposal?
Yes, that's the idea. Submit your proposed approach, again, at a non-confidential level. If you can share data without necessarily revealing the recipe, that's a good place to start. And if ICL finds that interesting, they'll contact you for further dialogue under NDA or CDA.
Thank you, Kevin. Going once again to ICL, is there any specific corrosive environment to be dealt with? Tony, Sandeep?
Yeah, so I will tell you today what these coatings are subjected to, and it's not truly representative of what kind of environment they see, but it is what the industry is using as a benchmark. So, for instance, these coatings will be exposed to salt fog or salt spray environments, and that's really to accelerate the failure mode. Typically, when we expose these test panels in a salt chamber, we will expose them after we've ramped them up to the degree or to the temperature at which these coatings will see in the field. We let these coatings basically come back to room temperature and then expose them to this very corrosive salt fog environment. And we go through cycles like this to see how well the coating withstands in terms of adhesion. Does the coating start to delaminate because of the cycling back and forth? But generally speaking, we're going to look at, say, ASTM B117 as a standard anti-corrosion or test for corrosion when we expose these high temperature coatings.
Okay, thank you very much. Moving on to our next question is actually a two-part question. First part is, are heat treatments allowable? And the second part is there a particular cost target in mind?
On the question of heat treatment, I'm not exactly sure I understand what they mean. And maybe they can explain this to me better offline. But generally speaking, these coatings are going to be applied, like I mentioned, under ambient conditions and then going through a bake cycle. That's typically what you do with silicon resins. You let them flash, at room temperature for, say, 30 minutes, and then you stick them in an oven at 250 degrees C for 30 minutes, and the coating is fully cured. So in terms of a heat treatment, if I try to understand what the caller is asking, I don't believe that there will be another cycle in which this coatings will see a separate heat treatment. So I think the answer to that is possibly not. Now, from a cost parameter, I think that's something ICL obviously need to think more thoroughly, and it's something we can definitely entertain offline. But keep in mind, some of the customers we're talking about here are not your, heavy-duty customers. They're customers who are making grills that are going to be sold in homes. So your additive needs to be sort of commensurate in terms of cost to what a traditional consumer might pay for a low-end grill.
Yeah, and I think from this is Sandeep. So from the perspective of commercially speaking, I guess it does also depend on what percentage a solution would go into a formulation at. Depends also on what's the degree of benefit gained, and here at ICL, we, by understanding that, we try to relay that information downstream to our customers, and oftentimes jointly with our customers go to their customers to help them understand the value gained and negotiate the right type of value for all parties involved.
Thank you very much to both of you. Our next question, does ICL have a method to measure corrosion resistance for this particular coating? And if so, would you be able to share that?
The answer is yes, and this would be something we'd be able to share with specific participants who are interested in submitting with proposals. We can certainly share that with us. I'll share that with them. But I did allude to the fact that salt spray is one of the primary methods into which this coating will be subjected.
Okay. Our next question, and you alluded to this a few slides ago, are there any chemistries that are currently off limits?
Yes, I think that answer or that question was answered in one of the slides. If you want to scroll back to that one slide, I think the elements that we listed there are the ones that we would deem to be off limits.
Okay, very good. Our next question, how quickly are you looking for a solution?
Well, we upon a number of these customer interviews I described, this is Sandeep, that I described earlier, we have heard from our customers that they're interested in a solution as soon as possible. So this isn't a need that we're trying to meet 2 years from now. This is a need that we're trying to meet right away. So as I think was mentioned earlier, we're not looking for a 3 to 4 year project. If there's a solution available today, or if there's a solution that can be quickly modified over the next few months to maybe sometime in 2016, that would be the ideal scenario.
Okay. We are quickly approaching the end of our time today. With that in mind, I will bring an end to the Q&A session. Don't fear, if you come up with a question after today's webinar, we will discuss in just a few moments how you can go about getting the answers to those questions. At the moment, I would like to have our attendees answer another brief question. And the question is simply, would you like to be contacted by a representative from ICL Innovation for follow-up? And it's a simple yes or no question. And you should be seeing that on your screen now. Would appreciate it if you would take the time to answer that question. And while our attendees are answering that question, I'll go ahead and move to our next slide. Namely, what can you do today? At the top of the page, you will see the URL for the ICL Innovation Gallery. That'll take you to the gallery main page so that you can see all of the different projects that are currently listed there, as well as obtaining the links for the individual projects and gaining access to the response forum themselves. While there, you can get more information about how to respond via the NineSites portal. Also on the screen, you'll see the Solution Provider Help Desk. You'll see our email address there, phd@ninesigma.com. PhD stands for Provider Help Desk. If you have any questions about how to respond, about how you go about responding, or questions just about NineSigma in general, please feel free to contact us at the Provider Help Desk. We can be reached by email or by phone. Our email address is there on the screen, phd@ninesigma.com, or we can be reached at area code 216-283-3901. I'd like to thank all of our speakers for their time today and their expertise. Thank you to our listeners. We appreciate your time and your patience during our audio difficulties. We look forward to receiving your proposals.